Hi there, welcome back here, guys. In this lecture, I would like to just recapitulate very quickly some information about the transactions. This lecture will be AI lecture, so you are free to skip this one. All right, so without any further waiting, let's start. Let's recapitulate how we are sending transactions to the network. Remember, we are constructing transactions, but we need to provide some fields, for example, from in the transaction to in the transaction. Then we need to provide a value, right? Value, gas limit, and also nonce. A very important number. Okay, gas limit usually for a transaction is only 1000, some value in a way, so it can be a lot of zeros, right? Okay, and the address is 0x, some address, and 0x address. Remember, this transaction is not sent like this to the network. First, what will happen, it will be encoded with the RLP encoding. Okay, it will be created, some transaction hash will be created here. So that's what you are basically sending to the network, will be row transaction with RLP encoding, RLP encoded and signed. Okay, so this part of the signature, this part RSV part, that's a part of the signature in this encoded transaction. And this encoded transaction is in a byte format, right? Hexadecimal sequence of a byte. So 7F and so on and so on. That it doesn't matter. And this is what's getting emitted to the network. This is getting emitted to the network. Okay, let's recapitulate nonces first. So let's imagine Bob is sending two transactions. Bob is sending two transactions. And first transaction, or actually let's say if the Bob has a 10 or 8 ether balance. So let's say 10 ether balance, and he is sending the transaction. First one, which is more important to him, is sending the transaction in a value of 6 ether. And the second one that's less important to him, he's sending transaction of 3 ether. That's less important, it is a more important transaction for him. The way it would work if the nonce wouldn't be sent here is that the transactions are not taken in order. So it's even though he emitted this transaction first to the network and this is the second one, it's not guaranteed that this transaction with the 6 ether will be taken first. So let's say in this case, maybe the transaction with the 3 ether would be taken first. This will be processed. So this means the Bob ether balance would decrease by 3. So the new balance would be 5 ether, the new balance. Which means that the transaction which is still hanging in a network, which is a 6 ether, wouldn't be declined because there is no enough balance on Bob account. So the more important transaction wouldn't be processed. That's why we have a nonces. That's the reason why we have a nonces. So every transaction has its nonce. And for example, if the Bob will provide here a transaction, which will this one will be nonce 2. So let's say nonce will be 2. And he will say nonce 5 here for this transaction. This transaction will be processed now first with the 6 ether. Okay, so now this transaction will be taken first, and this transaction will be hanging here. It will be even hanging here if I will send if I would this transaction will be processed because this is nonce 5. So I have to wait first until the transactions with the nonce 3, 4 are emitted to the network. Okay, so this will be still hanging here. We'll be waiting until the transaction with 3 is emitted to the network, and then 4 is emitted to the network, and then we could process the 5. It has to be in order. So that's our nonces, and that's why the nonce is important in this case. Okay, other important part about the nonces. Okay, it creates some uniqueness to transaction, and also I would like to try to talk about replay attack. Okay, so when you have this row transaction hash of your transaction, there is nothing stopping, as I was mentioning before. There is nothing stopping to some other people to get a transaction and re-emit it to the network. Which would mean when they would re-emit the same transaction to the network, they're basically creating duplicate of a transaction that has been already sent to the network. So naturally, this transaction will be declined. So if I will create here more copies of this, I will create here copy of this transaction, and I will create more copies of the transaction. I will re-emit to the network. They would be declined. Okay, so this wouldn't simply work. This would be declined. Okay, so no copying pasting transaction is not really simply not possible. Okay, but I was mentioning also when the hacker would now try, for example, to copy the transaction, so it would be copying the same transaction data as we have here. So the exact copy of the transaction would be created. And he would change the nonce to the next step, to the next nonce. So he will change the nonce to the next in order nonce tree. And the way it works, he has to sign the transaction here, because in order, when he would change here nonce, the entire message would change. So the previous encoded transaction with the RSV parts wouldn't be simply valid, okay? It wouldn't be simply matching. So in this case, he needs to resign the transaction with a new nonce. So he will try to sign the transaction, but of course, when he will try to send the transaction, he has to provide his own private key. All right, and this, with its own private key, it will create a new sequence of this raw transaction encoded data. And in this signed transaction with his private key, there will be new part of the RSV, right? So, and RSV parts basically telling us who is the signer of the transaction, because from these parts we can get a public key. We can get a public key from this public key, and from this we can get also address. From a public key we can get also the address of the sender. So if the hacker would even copy the transaction, the same field from to value gas limit nonce, but he would sign it with his own private key, this would result into this new sequence of bytes where the RSV parts would basically be saying that the hacker is sending the transaction, not the actual user, where the from is this from. So as you can see, it's very good protected by cryptography. I just want to talk about, I just want to recapitulate this basic stuff for you. By the way, we'll go again through all of this stuff here, all these transaction hashes. I would like to show you how this is encoded, but I will leave it for later, so we can now start again programming, because I think we have talked too much about the theory. So guys, once again, if you have any questions here related to this, just keep asking, and we'll continue in the next lecture. Cheers.